Okay. We're going to use what we saw here to construct the cosecant graph. Now, one thing I did here that was not a good idea, it worked fine for the situation we had. I put the length of our x segment, or whatever this length is, length of our known segment on the hypotenuse, and then I put the unit length on the vertical leg. That works fine, except that the length of our known segment could well be shorter than our unit length, in which case there's no way that would be on the hypotenuse of a right triangle, because the hypotenuse has to be longer than the unit. So what I would have done if I'd have been thinking ahead a little bit was I would have put this segment on the other leg so that the two legs wouldn't be restricted. We can put any lengths we want on the legs, but we're restricted if we try to put one of the lengths on the hypotenuse to only lengths that are greater than our unit. Okay, so here we have our graph of the sine. Here we have our unit 1. Now I take that unit and I construct, and I'm not constructing, I'm just sketching, but right here is our vertical leg, which corresponds to the unit length. Now, here's our horizontal position on our position on the horizontal axis. We want to know what vertical position corresponds to that. Well, we just go to the vertical coordinate and we put that down here. It looks like I overestimated that. Okay, there we go. Put that down here, and we have the leg of our right triangle, the horizontal leg in this case. Okay, so we haven't used the hypotenuse, and we're not going to use the hypotenuse. Now, we want to take the reciprocal, so we have to put a leg of length, of unit length here, and the reciprocal is going to be here, by reasoning almost identical to the reasoning, identical actually to the reasoning we used here. So I want to take our unit length and put it here along the horizontal leg. Having a little bit of trouble making that look purple, but there it is. And now this leg is going to be our reciprocal. So I measure the length of this leg. I don't actually measure it. I find it with the compass and I put it here. And maybe I'd better reverse the compass. Some of the mechanism's getting in my way. And I find this value. Okay? Now I can do that with a variety of other points. I want to take a second point where the vertical position is less than the unit length. So right here is a horizontal position that has a vertical position equal to the length of this segment. Now I construct this segment. It'll be a short segment, and that segment is going to be constructed again on a horizontal line, or horizontal segment. I didn't make that very horizontal, but you know what I mean. And we're going to start that segment here. It's going to be this long, so here it is. Okay, now I want to construct a vertical segment whose length is the unit length. And then I'll construct my hypotenuse. I don't really need the hypotenuse for anything, but I do need the whole triangle. So I do need the hypotenuse as part of the triangle. Now, we now want to put the unit length along our horizontal leg. So let's get that unit length again. Okay, and now we see that the unit length is greater than the base of our triangle. I'm having trouble operating the chalk and the compass at the same time. So that if I want the triangle to be similar to this one, I'm going to have to extend the triangle. In the examples we've seen so far, the triangle that the length that we're constructing, which would be the vertical leg of our triangle, here or here, was inside the original triangle, but that's not the case here. It appears that the vertical leg is going to now be longer. Okay, these two triangles are clearly similar, at least to the extent that I've constructed them or sketched them correctly. So now, what can we say about our vertical position? Well, it's going to be here, and I've got the wrong color. Okay, so this point is higher than this point. Okay, now why is that? Well, this represents a length shorter than 1, so the reciprocal of that length is going to have to be bigger than 1. If you take the reciprocal of a small number, you get a big number. If you have a number smaller than 1, the reciprocal is going to be bigger than 1. Okay. Now, we could do the same thing, just to emphasize, for an even smaller, an even shorter segment in the y direction corresponding to this x-coordinate. And I'm not going to draw it, but you should understand that, well, maybe I will draw just kind of a representation. It's hopeless to try to construct it with chalk. But we're going to have a very short segment here, and then our unit segment will be quite a bit longer. And because of the shortness of this segment, I'm already having trouble drawing the triangle. The triangle is going to have a very steep hypotenuse, so that when we sketch our leg of length 1 here, we're going to have to go up here quite a ways, probably interfere with the other pictures. And this isn't accurate at all. It's not being constructed. But you should get the idea. We're going to have to go way up here to complete a similar triangle, meaning that our y segment corresponding to this point, our vertical segment, is going to have to go way up here. And we can see that the closer we get to x equals 0, the shorter this segment is going to be, and the steeper the hypotenuse of this triangle is going to be, and the further we're going to have to extend our hypotenuse in order to meet it with this vertical line. Because, of course, this leg of our new triangle is always going to be of unit length, of the same length as this segment. Now, as the length of our vertical segment approaches its maximum, which is going to happen at the position here corresponding to a quarter cycle around our unit circle, around our reference circle. It's not a unit circle at this point. Well, I guess I can sketch it, okay. It just, again, sketching. The lower leg of this triangle is going to be about this long. The vertical leg is going to still be our unit distance. And our triangle is going to look like this. Now, when we bring our unit length down here, we're going to get quite a short vertical leg. So if I, using the compass and everything, I'm not going to actually do that. But if I do that, you see that I'm going to end up with a vertical leg here and a point way down here. Okay, well, what happens is our graph then is going to look something like this. And we're going to have an asymptote with the y-axis because as we approach 0, the steepness of the hypotenuse of this triangle is going to approach infinity. It's going to get steeper and steeper till it's almost vertical, so that to construct our similar triangle, we're going to have to go up higher and higher, and there's no limit to how close this triangle can get to vertical, so there's no limit to how big this result can be. Now, symmetry tells us that, well, the symmetry of this curve about this line, the symmetry of our sine function, which we can trace back to the nature of the reference circle, dictates that we have another vertical asymptote here. So that this portion of the cosecant function, the cosecant graph, is bounded by an asymptote here and an asymptote here. And we can see why this asymptote occurs because, of course, as we get closer and closer to this point, our segments, again, get shorter and shorter. So when we construct the reciprocals, our results will be bigger and bigger. Then we can use more symmetry. And of course we could construct this point by point, but we can use another symmetry argument to show that what we get over here is going to be symmetric through this point with what we have here, so that we're going to get a graph that looks something like this. Now, the value of this function, the function is undefined. So here we have, well, let's see, okay, cosecant graph in orange. And the cosecant graph is undefined at these points where we have vertical asymptotes. Note the spelling of asymptote with a P. People misspell that all the time and mispronounce it too. So just be conversant in polite society. You want to be able to spell that right. Okay, and pronounce it correctly. Okay, well, here's our construction. And this completes the construction of a cosecant graph. Of course, we can do all this for every point on the sine graph, for any unit length that we want to choose.